So hello, good morning, everyone. So yesterday we discussed about Dm Vpn phase 1. So in Dm Vpn phase 1, we used a hub router. So it is connected via ISP. So we have R2, spoke 1, and we have R3, spoke 2. So on the hub, we configured MGRE, that is multi-point GRE, and on the spokes, we used P2. So one disadvantage in Dm Vpn phase 1 is always your traffic will go to the hub and then it will reach to the another spoke. So there is no direct spoke to spoke communication. So this was a major disadvantage in Dm Vpn phase 1. So if we talk about the configurations, what we did yesterday. So on R1, so we created a tunnel. So then we provided the IP address of the tunnel. Then we specified the tunnel source. So either the exit interface or the NBMA IP. Correct? So we didn't specify any tunnel destination because it is a MGR. Then we use the command tunnel mode GRE multiple. Just note down this, it will be helpful for you. So then we use the command IP Nhrp network ID. So why we use network ID? In order to differentiate your Dm Vpn network. So it is local. You can give any number on R1, R2, and R3. But if you keep it the same, it will be helpful for your troubleshooting. Then we use the command IP Nhrp map multicast dynamic. Why we use this command? In order for the spokes to dynamically register with the hub. Here, they will send an Nhrp resolution request and a resolution reply. Correct? Correct. Right? No? Okay. Yesterday's video. Clear? Now, moving on to the spokes. So on the spokes, please make a note. I will wipe this. I'll write here configuration on spoke 1 and spoke 2. Don't try to remember the comments. Understand the comments, why we are using this, why we are using this. Then you'll automatically remember the comments. Don't mug up. So I need to configure IP Nhrp map multicast dynamic on the hub. Why? It is mandatory to give, but it is locally significant. But if you give it same, you will be able to identify in the same Dm Vpn tab. Mostly inside the same Dm Vpn network, we give this number the same, just to identification, just for identification, like how we have router ID in Ospf and Eigrp. So what your router ID will do? It will just identify a router. It may not be reachable, right? See, let us consider we have used router Ospf process and we have used Ospf router ID as 1.1.1.1. So do you think that IP should be reachable to any other router? No, it's just to identify the router. In the same way, this is used to just identify your Dm Vpn tunnel. Okay. So, now on this box. So interface, tunnel 0. Again, we created a tunnel here. So this is tunnel. It's not T0. It's tunnel 0. Tunnel and the number. Any number you can specify. Now, so we provided the IP address again here. IP and the mask. So since it is a point to point. So what do you mean by point to point is you need to specify tunnel source and the tunnel destination. So we specified the tunnel source. It can be either exit interface or NBMA IP. But your tunnel destination must be NBMA IP only. Then we used the command IP Nhrp network IP. Number. Then we used the command IP Nhrp map. New entry. New entry. We are not there in previous class. Right? Yes. So IP Nhrp map. First, the tunnel IP of the hub. And then the NBMA IP of the hub. We call tunnel IP or logical IP as well. So what we are doing on the spoke is we are mapping the registration. So where R2 should forward his registration towards your hub. Even R3 also, he should proceed to your hub. That's why we are statically mapping on the spokes. What is the next command? IP Nhrp map multicast. So in map multicast, you need to use NBMA IP of the hub. Correct. This is NBMA IP of hub. This is also NBMA IP of hub. So why we use this command? In order to forward your multicast address, because your routing protocols like Eigrp and Ospf uses multicast address. That is 224.0.0.10 for Eigrp, and for Ospf it is 224.0.0.5 and 6. So in order to forward this multicast address, where it should forward? It should forward on the NBMA. It should send towards the hub. Clear? Now, what is the next command? IP Nhrp NHS. Now you need to tell who is my next hop server. This will be the logical IP of your hub. Correct? Or if confusing, write tunnel IP of the hub. Welcome. Welcome. Well, because girlfriend only we go, not mother and father. So we can talk after class. But they also know, they should also know I'm in the class. Something new? Yes. You have to watch the recordings, previous recording, and ask me the doubts. Name, good name? Vijay Kumar. Finished with your routing? So okay now. So now if we talk about Dm Vpn phase 2. Again, the same scenario. We have a hub. Spoke 1. And we have spoke 2. So now with Dm Vpn phase 1, what we used to configure on the hub? MGRE, multi-point GRE. And what about in spokes? Point to point, right? Here in Dm Vpn phase 2, the only difference is on the spokes, you'll be configuring MGRE. And even on R3 as well, MGRE. This is the only difference. Means we'll not be specifying any tunnel destination. That is the difference. Easy, right? No smile came. Good. Easy, right? Tell me.
Okay, we said actually in Dm Vpn there is 3 phases, right?
Yeah, correct.
Okay, this phase means it's a different type, or it's like if you go to the normal VPN, there is 2 phases. One is ISAKP
So inside
phase
site
1
to site, again, these are different phases.
Okay, I mean phase in the sense it's same. It's a
Like
configuration
type.
difference, or
Yes, configuration difference.
okay. So the first one we studied, the phase 1.
Yes.
That is enough for the Dm Vpn, basically.
But there is no direct spoke to spoke communication, right? In phase 1, we can't directly.
Okay.
So now this is the improvised version, next version of Dm Vpn. We can say phase 2.
Oh, okay. In phase 2 or in
like
phase
how we have
2
versions in VTP, we have 3 versions, right?
Yeah.
So version 1, version 2, version 3, correct?
Yeah.
So what was the difference in version 1, version 2? So in version 1, there was no FDDI and token ring support, whereas in version 2, it supported. So some improvisation was made. What about VTP version 2 and version 3? So modes was changed. One mode was introduced newly, that is off mode. Then authentication improvement was made here. So many improvements. Even MSTP supports synchronization of MSTP configuration. In the same way, in Dm Vpn phase 2, it's same like your.
It's basically a new version 2.
Yes.
Okay, got it.
Okay.
Because actually I doubt that, like when we say about the normal IPsec VPN, we said that it is working in 2 phases, right?
I
thought it's something like that.
That is ISAKP and IPsec you are talking about.
Yeah,
phase
I thought
1
it's
and
something
phase.
like that.
Yes.
Okay, this is like a version.
Yes.
Okay, thanks.
But in the interviews, don't say it is a version, it is a phase.
Okay, sure.
Okay. So now, in Dm Vpn phase 2, you can have direct spoke to spoke communication. It's possible. So the first packet will always go to the hub and then to your spoke. Let us consider we want to communicate between spoke 1 and spoke 2. So first packet will always go via the hub. From the second packet onwards, they will establish a direct spoke to spoke tunnel. Clear? And one more thing I forgot to tell you yesterday. Hub, no, we basically call zero touch configuration. So what do you mean by that? So what do you mean by zero touch configuration is, let us consider I want to introduce one more spoke here. Let us consider we want to introduce one more spoke, that is spoke 3. Means you will not be touching the hub for the configuration changes. Only you will be configuration changes will be made on the spoke. That's why we call this as zero touch. Means once hub is configured, we will not touch the hub at all. Only if any new spoke is introduced, you need to go and configure on the spoke only. Only in DM. Yes. Because we use the command IP map multicast dynamic, right? What do you mean by dynamic? These spokes will register dynamically. So we will not touch this hub at all. Only you will be going and configuring on these spokes. So one more thing in Dm Vpn phase 2 is we can't do summarization. Why we do summarization? Size of your routing table. So any other benefits doing summarization? One is reducing the size of the routing.
Reducing the size.
Okay, any other benefits? Save the memory, very good. Then good. Save the memory, save the CPU utilization. Then about link flaps. I hope you know about link flaps. So what we saw yesterday in OSPF, the link was flapping. When you send a summary, no, your link flaps will never be affected because you're sending a summary, right? Your routing table will not be flapping. That is one more advantage of doing summarization. Clear? Link flaps, link flaps. What do you mean by link flaps? Link is going up, coming down, going up, coming down. So that will not be affected. Means your routing table, routing entry no, will not go up and come down, go up and come down because you have sent a summary of that. So that's why link flaps will never affect. One more point here. So this we'll discuss in the lab only, why we can't do summarize. Done? Okay. Now we'll proceed to the lab. We'll see how the Vpn phase 2 works. And we'll implement BGP in Dm Vpn phase 3. So you can implement anywhere. So I'll be showing you BGP in phase 3.
Spoke to spoke will communicate each other. First time
Go to the hub. Nhrp resolution request, registration. Yes. Yes. But in phase 3, that was again removed. Direct spoke to spoke. We'll talk about phase 3. That's why we can do summarization on the hub in phase 3. This lab we did yesterday. It's okay. So we'll introduce one more spoke. First, we'll configure this. We'll check the connectivity. Then we'll introduce one more spoke, one more set. So we'll tell the configurations on our. So again, small, notepad is small. Fine, right? Notepad visible. You should tell me how. Edit. Okay. Font. 40 or 16. Okay. Okay. So host name. So interface 0%. IP address will be 192.168.14.1/20. introduce a default route. So today we'll not use default route. We'll use OSP protocol. So one more key point to remember: never enable. So let us consider we are enabling Eigrp. So on the tunnel and on the NBMA, never enable Eigrp. Use different protocols, not the same. Because how you will send a tunnel interface inside a NBMA? You can't send that, right? So you need to use different protocols. So now OSP, because I can show you the summary. So router OSPF 1. So network 192.168.14.0. So if I use 1, then okay. You need to use subnet mask or wildcard mask. Yes. What do you mean by wildcard mask? Correct. So it's opposite of subnet mask. Correct. You also work? Oh, wow. But you need to provide wildcard mask. Done the lab? Area 0. So network. So done. This is done on R. You should use wildcard mask, because always OSPF uses wildcard mask. So on R2, so interface Z0 bar 0 will be 14.2. Interface Z0 bar 1. So IP address will be 24.2/24. Interface Z0 bar. Yeah, 24.2. Right? Z0 bar 1. What interface? Z0 bar 0 is 14.2, right? Sorry, 4. Okay. 24.4. Okay. So IP address will be 192.168.34.4/20. No shit. Enable the voice. So it's 14.4. So it's 24.4 and 34.4. Done. So go to R2. So on R2, so interface Z0 bar 0, 192.168.24.2, and router OSPF 1, you need to enable on 24.2. So on R3, so interface is 0 bar 0, 34.3, router OSPF 1, 34.3. So now you need to configure the tunnel. So go to R1, establish tunnel. So interface tunnel. So IP address will be 172.16.123.1/24. Tunnel source. You use exit interface Z0 bar 0. And tunnel mode will be GRE multi-point. Why I should use this command? Very good. Default it will be point to point. Yes. Then IP Nhrp. So network ID 123. Any number you can use is local to your router. Then IP Nhrp map multicast. Create a loopback. 0. So IP address will be 1.1.1.1/32. Now on the tunnel, we will be enabling EIGRP. So router EIGRP 123. Network 172.16.123.0. Can use wildcard mask as well. Then on the loop back as well. And no auto sound. Yeah, this is on the hub. Now go to R2. Create a tunnel. Interface 0. IP address will be 172.3.2/20. Tunnel source. Yes. Good. So you want to use that or use exit interface. Tunnel source and tunnel mode will be GRE multiple in phase 2. Multi-point. Then IP Nhrp network ID. 1, 2, 3. So now you need to statically map using the command IP Nhrp map. So first the logical IP of the hub, that is 172.16.123.1. Then the NBMA IP of the hub, that is 192.168.14.1. Then IP Nhrp map multicast. Now I need to use the NBMA IP of the hub, where I need to forward my multicast packets to 192.168.14.1. Next, IP Nhrp NHS to tell who is my next hop server. That is your logical IP of the hub. That is 172.16.123.1. Done. Now go to R3. Sorry, enable EIGRP. So router EIGRP 1. So network. So 172.16.123.0. Wildcard mask and network loop back. No auto sound. Just copy paste this. First create a loop back. So now just change the tunnel line. Everything remains same. So tunnel source, multi-point, network ID, map multicast, and NHS. So even EIGRP remains the same except the loop back. The copy paste. This is the full configuration of Dm Vpn phase 2. Copy paste. Just wait. Need to wait for adjustments. Now OSPF has done. Check the reachability of NBMA. That is 192.168 dot. Sorry, not from R1. Check from R2. Okay. 192.168.34.3. Success. One turn. No adjacency is found. IPN chapter should register to. Yes, it has registered 172.16, 123.2. And what is the NBMA IP? 24.2. And one more cache, that is 172.16.123.3 and 192.168.34. That is your art. So how it has learned? Can you see here? Dynamic. That's why we don't touch the hub. Zero touch configuration. So it will these spokes will automatically register towards the hub. Now show DM. There are two entries and they have dynamically created it. Now, so let me go to R2. Just trace. Trace to, so let's find the entry first. Show IP route. Yeah, sure. Where is the another entry? If you talk about hub, no, just wait. Show IP route. Yeah, sure. I have both the entries here. Yes, I have both the entries. I have 2 and 3 as well. So now tell me why I'm not getting this 3 entry in R2. Wait. It's because of split horizon. What do you mean by split horizon? Loop, what do you mean by that? Yes, loop will not be there. Correct. It is used to avoid the loops. What do you mean by split horizon?
Because when we send the information, routing information to that interface, again that information.
Very good. So on the same interface, we can send that route again to another route. Very good. So now what we need to do? We need to go and disable the split horizon. So go to R1 and disable the split horizon. So by default, it's in yes, good. So go to interface, tunnel 0, and no IP, split horizon, Eigrp 120. So if you don't enable this, it will be enabled for RIP. Even RIP has split horizon. So you have to mention Eigrp and the autonomous system number of the Eigrp. Enter. Now again they will resync. Now if you go and check on R2, I'm able to see 0.0.0. Clear? Now one more problem. So when I trace to 0.0.0.3 numeric, first packet went via the hub. 123.1 is the IP of the hub, and 123.3 is the IP of the second spoke. I just use means in order just to what you say, not to do domain lookup. DNS will be by default enabled, right? So in order to just avoid the DNS lookup, I use numeric. You can trace as this like this also. See, it will take time. Numeric just I use. I'll tell you about this numeric. See, it is taking more time. DNS resolution. DNS query, DNS. See, numeric means only numeric will come. Means only letters it will display. Yes. See, it's taking time. Now the problem is when the second packet is going via the hub, we don't have direct tunnel to tunnel communication. Why? Because check show IP route Eigrp. Can you see the next stop here? What is the next stop? Who should be the next stop? 123.3, right? Now tell me what to do. Again, this is Eigrp. Problem. Any idea? Yes, online guys?
Every router information comes with the next stop.
Next stop. Okay. What we should do then? Disable next stop cell. So go to R1. So this is mandatory. So interface tunnel 0. No IP, next hop self, Eigrp, ASL. You need to disable this. Otherwise, always your next hop will be the hub's IP. Now, as soon as you disable this, now just come to R2 and check the Eigrp. Oh, can you see what is the next hop now? Changed. Now trace. Direct spoke to spoke communication. But the problem with phase 2 is you can't do summarization. I'll tell you why. Let's go to R1 and do summarization. For summarization, avoid the loops. Oh, let us consider we have done summarization. So how it will avoid the loops? Any idea? It will create a null 0 route. Okay, so let's go to phase tunnel 0. Let's enable the IP summary address, Eigrp, ASN. Let me summarize 172. Let me use 0.0.0.0, 0.0.0.0. So anything to everything. I'm summarization. So can you see on the router where you have summarized, it has created a null 0 entry just to avoid the loops. What is the metric of null 0? Very good. 5. So now come to R2. So the problem is, if check show IP route, Eigrp. So it has created a summary, that is good. But what is the next hop? Can you see the next hop? It will be always pointing towards the hub because R2 doesn't have direct Nhrp mapping or any tunnel with the hub. Your trace will always go via the hub. This is the problem in it. Can you see? Again, try to trace. This is the problem that we can't do summarization in phase 2. But in phase 3, they will establish a dynamic tunnel between R2 and R3 so that it will be free from the hub. So here first packet is going to the hub, then going to the routes. Who is sending Nhrp resolution reply? Hub, right? So that's why if you check the routing table of Eigrp, can you see what is the summary is pointing to? Because I summarized on the hub, right? That's why we can't do summarization in phase 2. Clear or not clear? Clear? So any doubts still here? This is about phase 2.
Chetan,
Yes.
okay, just want to check in phase 1, actually in hub, we were using tunnel mode GRE IP, right? I mean,
GRE
normal-
multi-point. It was MGRE tunnel in phase 1. Only point-to-point tunnels we used in the spoke.
I'm sorry, can you just repeat?
So on the hub, no, we're talking about phase 1, right?
Yeah, phase 1.
Yeah, on phase 1, we used the MGRE here, multi-point GRE. And on the spokes, we used point-to-point.
Point to point. Yeah, that's what I mean. Spoke.
Yes.
In phase 2, spoke, the configuration difference is in spoke, we have to use tunnel
Everywhere
mode
MGRE.
multi-point,
Yes.
MGRE.
This is the change in phase 2.
Okay, and as we are using the Eigrp, we need to disable the next hop.
Yes, you need to disable the split horizon and you need to disable the next hop.
Next hop. Okay.
Clear?
Yeah, clear.
So anybody has any other doubts? Any doubts? Clear? Okay, all right. Let's move on to phase 3. Now phase 3 is interesting. Again, you say wow, why? Because only one change, one configuration change.
MGR and one is MGR and one is one.
But there is no direct spoke to spoke. You will not be able to come because since you are mentioning the tunnel destination.
And in phase 2, you said zero touch configuration too, right?
On the hub. Okay. So I didn't introduce one more spoke, right? Okay, we'll introduce one more spoke.
Yeah, sure.
But we'll just save this configuration. say the configuration on R4. On the R2. And on the R3. So now just stop this. So we'll introduce one more router. Let me add R5. And one more IP. So 16.123.5. It's all confusing. We'll take. So we'll configure on R5. We'll have a loop back. 5.5.5.5/32. And the IP will be .5. Okay, we prepare our notepad. Just take this configuration of R3. Copy paste. So R5. So what is IP address? IP address will be, okay, I didn't cover that. Okay. 192.168.45.0 /20. So it is 192.168 dot. Any dots? No, no worries. Oh, AC dot. Yes. Yes. I thought Dm Vpn dot. So okay, 45.5. Correct. So we have a loop back 5.5.5.5. So we need to enable in OSPF. That is 45.5. Interface channel 0. So the IP will be 123.4. Source remains the same. Multi-point, network ID, map multicast, and NHS. So we need to change the look. No? So go to R4 and you need to configure that interface. This is 0.3. So we just copy paste this on R5. We show IP interface. They're all down. So interface range. So 0/0 to will keep. Yes, we'll take this. So we'll configure the interface 0/3. So the IP address will be 192.168.45.4/20. No shit. So do show run pipe section OSP. So router OSPF 1. You need to enable on 192.168.45.4 wildcard mask area 0. Enter. Go to R5. Copied already. For the adjacency. So did I touch the hub? No. Just introduce one more spoke and everything I went and configured on the spoke route. What is the by default Ospf timers? What about hello? Yes, you. 10 and 40. 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 What? Any other time? 10 and 40 or 30 or 120? That okay, you changed your mind. Okay, 30 and 120. Same 10.40. Select anything. 1040 or 30 120. Then you go for 1040. What about online, guys? Yes, BB. What is the by default Ospf timers?
It's 1040.
1040. What about Mohammed?
1040
Okay.
or
One more
BMA.
Mohammed. Is not there. Salva Kumar. Okay, let's type something. 10 and 40 Mohammed. Okay, Salva Kumar. Is not there. What about Tarun? He's also
10 and 40.
10 and 40. Very good. That is wrong. So whenever anybody asks, what is the Ospf timers, you need to tell it depends on the network type. Never tell 10 or 40 or 30 or 120. It depends on the network type. Because every network type has different hello and hold on timers. What is this network type? Very good. So we have BMA, broadcast multi-access. We have NBMA. We have point to point. We have point to multi-point broadcast. And point to multi-point non-broadcast. These are the network types. Broadcast. So if you talk about the timers in BMA, so hello and hold is 10 and 40. For NBMA, it is 30 and 120. Point to point, again, it is 10 and 40. So for point to multi-point broadcast and non-broadcast, it is 30 and 120. So it depends on the network type. Never tell either it is a 10 or 40 or 30 or 120. Yes. No. Yes, correct. Even point to multi-point broadcast is also dynamic. Only here you need to use neighbor command in NBMA and in non-broadcast. Only in non-broadcast you will use neighbor command. Yeah. No. This is done in routing. Okay, never. No. Okay. Yeah. Okay, we'll move. So let's check on R5. So always tell it depends on the network type, even in the interview as well. So show IP route here. So we have created a summary. So let's remove the summary from R1. So on R1. So to show a interface. Just go here and remove this summary. No. Type it out. Yes. Now I remembered. Change the font size. 16. What? Show IP route. EHRP. Can you see now it has learned 2 and 3. If you trace 2.2.2.2 new first, so from the second onwards,
So in this case, which type of OSPF method?
OSPF is used underlay. That's why first, second, third class, underlay and overlay. There are two types of, you need to watch that.
Yes.
Otherwise, watch that and come back to me if you don't understand. That is, we use underlay. For underlay, we use different protocol, and for overlay, we use different. Just watch the videos. I'll give you the drive link. You can come back. Otherwise, wait after the class. We'll discuss. Clear? Now you can trace for 3.3.3.3. First, always via the hub. So from second onwards. Now we have direct spoke to spoke communication, but tunnel has not been created on the Nhrp cache. You don't have a dynamic tunnel. That will be created in phase 3. Yeah. Any doubts? So now we'll move on to. I hope clear online guys.
Okay, for the zero touch configuration, actually, what are the configurations you have done?
I didn't touch on the hub, right? I didn't touch anything.
Yeah, you didn't touch anything on hub.
Yes. You want to know the configurations of the hub?
No. Is there any configuration spoke? I mean, the normal configurations are enough, or
Normal configurations. What I did. Just check here on the notepad. So these are the configurations I did.
okay, tunnel zero?
Same configurations. What I did. Just I changed the tunnel IP. So everything remains the same.
Okay. This is the same way what we did on .2 and .3, right? I mean, R2 and R3, right?
Yes. Clear?
Yeah.
So one more point to remember, just go to any of the spoke, check the Nhrp cache. Show IP, Nhrp. So show IP, show Dm Vpn. So we have 2 dynamic entries and 1 static. So we have 123.1, 123.2, 123.3, and 123.4. Yeah. Yes. After 2 hours, if there is no communication between different spokes, it will flush. Again, if you communicate, then it will come.
We communicate first to Nhrp.
Yes, again same will follow. Yes. Yeah. Okay. Now we'll move on to phase 3. Dm Vpn phase 3. So again, same topology. We have the hub. We have the ISP. So we have R2 and we have R3. This is spoke 1. And this is spoke. So MGR everywhere remains the same. So only one extra command. So on the hub, you need to configure IP, Nhrp, redirect. I'll talk about the redirect command. So this is the command. You need to go to the tunnel and you need to configure redirect. And on these spokes, you need to configure IP, Nhrp shortcut. This is one extra command you need to add in phase 3.
Any space in between shortcut?
Yeah, IP NHRP space shortcut. No, no. So R2 and R3 both will send a resolution request, correct? Request. So for a resolution request, R1 will reply with NHRP resolution reply. NHRP resolution reply. So this is the we have to write same reply. Okay. Now, so what you mean by redirect is, so as soon as R2 sends a resolution request and gets a resolution reply, so what R1 will do is R1 will redirect the traffic, saying that you have a better path to reach to the spoke 2. It will send a traffic indication message. I'll show you in the Wireshark. One. Traffic indication. So what I mean by traffic indication is, so how the first hop will go? Let us consider R2 wants to reach to R3. It will go to the hub. So why? Because dynamics, what is it? NHRP cache entry is there. So now when R1 checks, when you configure this redirect command, no, so what it will do is R2 will establish a direct route called H route. This is your NHRP route. So direct route to the R3 spoke. And even the R3 will establish a H route, means a direct route to the another spoke with the help of traffic indication. This is sent by your hub. That's why we will have a direct communication between R2 and R3. So now we don't require any split horizon, any next hop.
So, the traffic indication is sent by the hub to
Hub.
both spoke only?
Both spokes. Yes. Because both will register, right? From both, you are getting the resolution request and indications. That's why we can summarize in phase, because no R2 doesn't depends on the hub. We have a direct entry, right? So that's why we can do summarization in phase 3. Clear? Phase 3 is possible. I'll show you. So not understand, don't worry, just go through this.
Chetan,
Yes, tell me.
okay, when in spoke, if we
Mhm.
create a IP NHRP shortcut, right?
Yes.
Then the spoke will raise a NHRP resolution request.
No, before
But
that only it will send, right? Even in phase 1, I have shown you. So this is not related to these commands. Why we enable these commands is in order to tell the hub that there is a better path for the spokes to reach to another spoke. Didn't understand?
Okay. Yep.
Okay. So normal NHRP resolution reply happens in phase 1, phase 2, and phase 3. So in phase 3, it is just the traffic indication is sent with the help of redirect command. And these will create a dynamic. I'll show you in the lab.
Then what is the use of this NHRP shortcut command?
It's just to whatever the R1 has said, no, that traffic not to register these. So NHRP routes in your routing table, we use shortcut.
Okay.
Just to install these routes.
Okay.
Shortcut. These are shortcut routes because we have direct entry here. Just to install this shortcut entry, we use IP NHRP shortcuts. Routing table. Yes, R2 and R3 direct route. direct route. Okay. So before starting the lab, let's take a short break. We'll come back because long way to go. So here we'll be enabling Eigrp, Ospf, and Bgps. Okay. So today, little bit till 1 o'clock. We'll start at 12:20. So let's proceed to the lab. So IP and Nhrp redirect. Command on the hub. Just shut down. And then we'll re-enable it. Go to R2. 70 IP and Nhrp shut. Shut down. Go to R3. Right, so shut. There for 2 minutes. Sorry, where are went in? So not now. R5 as well. Shut. Done. So first go to the hub and then motion. And then on the spokes. So now let's capture. So go to R2. Check a pick. Go to pick. Direct one. So if you check the routing table, can you see H route here? Install a H route. Direct to spoke. So go and check the yes. Yes, it's directly correct. That's why it established a tunnel between direct spoke to spoke. If you check the Wireshark, so I'll check. Can you see traffic indication here? So what it is indicating? Just go inside mandatory part. What it is indicating? Don't come to me. Directly go to 0.0.0. It's redirecting. It's indicating the spokes to directly go to 3.0.0. Don't come to me for this information. Clear? Clear?
Yeah.
No. So now we'll go and enable the split horizon. It's not necessary. So interface turn 0. So IP split horizon. Eigrp 120. And IP next offset. It's not required, right? Because we have a direct tunnel. So now go to R3 and ping into 2.2.2.2. One minute. So it has created dynamic tunnel. This is done. DT1. They have the information. So it should be sent to sports. Sure. And re-enable the tab. Here's a problem. We don't require it. What is the interface settings here? I enable this. Don't require that. No IP. Wow. Sure. This way. Let's go to R2. So initiate pin. Go to R3. Initiate pin. For another spoke as well. So go to R5. Initiate pin. Reach. Now. So go to R3 and trace. Trace to 2.2. Numeric. Rightly going. Trace to 5.5.5. Check the Nhrp routes. Show IP route. So it is creating for 123 for 123.4. That is 5.5.5.5. Can you see it is misbehaving? It is not creating for 116.123.2. This is bug. Show Dm Vpn. Created a dynamic tunnel. Just a bug, guys. So it needs to work. So even if it disables, enable split horizon, no, it should work. So go to 0 IP split horizon. Eigrp 23 IP next. comes. Go to R2 and trace. Then you need to enable split horizon. You need to disable that. When I did in the morning, it's working. So it's a bug, guys. So don't worry. We don't require any split horizon. Our next upsell. So we'll do the same lab tomorrow as well. So I'll show you we don't require that both the commits. So let's proceed to BGP. So I'll disable it. So I'll remove Eigrp. So no router. Eigrp 123. Everywhere. And R3 as well. So now we'll enable BGP. So on the hub, it will be ASN1. On the spokes, so ASN2. And on R3, it will be ASN3. Okay. Let's go to R1 and enable BGP. So router BGP 1. Neighbor 172.16.123.2. Is the remote AS? Remote AS will be 2. Enter. So we have one more neighbor 172.16.123.3. Remote AS will be 3. And you have to authorize the network. That is 1.1.1.1 mask /30. So go to R2 and enable BGP. So router BGP neighbor 172.16.123.1. What is the remote AS? Remote AS will be 1. And you have to authorize the network. That is 2.2.2.2 mask. Performing the adjacency. Now go to R3. Enable BGP. Go to BGP3. Neighbor 172.16.23.1. So remote AS will be 1. Advertise the network 3.3.3.3 mask /30. How to check the BGP neighborship? Show IP BGP something. R1 adjacency with your R1. So go to R2, check the neighborship, show IP BGP something. One neighborship, and go to R1. So R1 should have 2 neighborship, one with R2 and one with R2. So everything is fine now. So go to R2. Think able to reach trace. This is how you enable BGP. This is eBGP. Now we'll form with iBGP. So iBGP will create problem. So let us take the autonomous system number as 123 and the BGP routes. Please check the BGP routes. Show IP BGP 123. And I have on R3 as well. Show IP So what do you mean by this? Don't say I don't know. What do you mean by 0.0.0.0? No,
It's directly connected, right?
directly connected. Okay.
You mean null?
Hmm?
Null zero?
Reserved.
No.
How it is reserved? Yes, tell me, Anand guys. What do you mean by next stop as 0.0.0.0? Self-originated. Good. Can you see? This is originated by R3 only. We call this as self-originated routes. Always the next stop will be 0.0.0.0. Self-originated. Good. So go to R1, disable BGP. So now we'll be forming with the help of IBGP. So we'll use the autonomous system number as 123 over here. Shut it down. Don't require this. So go to R1. So can I configure two BGP ASNs on a particular router? No. Router BGP 1. Now configure router BGP 123. Enter. So neighbor 172.16.123.2. What is the remote AS? Remote AS will be again 123. Just change the IP. There is 123.3 and remote AS will be again 123. Why notification? It's a notification message. Right? Why? Why I'm getting a notification message here? Check the BGP table. So let me disable this. No logging consent. Check the BGP. Show run pipe section BGP. Because of wrong AS. So I have configured. What is the remote AS? There it is. 2. Yes. That's why a notification message. Even in the notification message, you will see wrong AS somewhere. Where you can see, can you see? Appear in wrong AS. Okay, continue. So go to R2. Even here also it is notified. So no router. Just let's enable router BGP 120. Enter. We have neighbor 172.16.123.1. What is the remote AS? Remote AS will be again 123. So advertise the network 2.2.2.2. Didn't advertise on R1. So go to R1, advertise the network. Specify the mask / go to R3 and change the ASN. So no router BGP 3. So router BGP 123 neighbor 172.16.123.1. What is the remote AS? Remote AS will be 123. Advertise the network 3.3.3.3 mask slash check the adjacency. Show IP BGP summary. What adjacency I have? So go to R1.
It isn't just a doubt.
Yes, tell me.
For BGP,
BGP routes?
we can create multiple BGP instances in a router, right?
No, you can't create. They'll prompt you error.
Oh, okay.
See,
So what about the other protocol?
let me try. I have 123 running already. Let me create router BGP2. What is it?
For the other routing protocols, like OSP.
You can create queue. You can create up to
Oh.
32 instances for Eigrp and 32
Okay.
for OSPF. Please check. I'm not sure.
Yeah, no worries. No worries. Yep.
Okay. So now, what I was showing. Okay. Show IP BGP summary. What adjacency is fine. So go to R2 and I have one adjacency. Show IP BGP. I'm able to get 1 and 2. Where is 3? Why am I able to get? BGP problem. What?
Because R1 and say all three routing is same is. So R3 center is route to R1, but R1 not is center.
Advertise. Why?
Because it is coming in the same MS, so that's why it's not working.
That only what we call that as split horizon. IBGP split horizon. So how to mitigate that split horizon? Or basic thing is full mesh. So we don't use full mesh, but I will show you with full mesh, then we'll see with the route reflector. So let's go to R2. So interface, router, BGP, 1, 2, 3. So establish a neighbor 172.16.123.3. So remote AS will be 1, 2, 3. Enter. Bouncer. Not a bouncer, right? So go to R3. So router, BGP 123. So neighbor 172.16.123.2 and remote AS will be 123. From adjacency. Now check show IP BGP. Okay. Here IP BGP is slow. Why? Wait. Yes. Why BGP is slow? Why we call BGP as a slow protocol? It uses TCP three-way handshake. So before doing any data transfer, first it will establish a three-way handshake. What is the port number?
179.
179.
For all the data transfer, it will establish or for
First
the
it will establish the connection, three-way handshake, then only data transfer.
I mean, for the neighborship, it will use the TCP Sinaka.
Tell me.
For the neighborship only, it's using TCP, right?
Yes. For the neighborship. Do show a 5 section BGP. Then I didn't advertise 3.03. That was the problem. Network. Mask slash show IP BGP. I have 3 entries. So on R1 also, we have 3 entries. And on R2 also, we'll be having 3 entries. Show IP. Ping. Then entries. This is one way. That is full mesh. Now, same lab we'll do with the help of a route reflector. Now tell me why we need a route reflector. My question is why route reflector?
To avoid the IBGP loop.
Why route reflector? Why we need route reflector? Filtering. No, I'm not asking filtering. I don't want to filter. Why we use the concept of route reflector?
It's because of the IBGP loop. it won't work. I mean, it won't create a,
IBGP. So we use route
avoid the-
reflector in order to avoid the full mesh.
yeah.
Correct? So
Yep,
in route reflector, so we'll be having one route reflector server. So we'll make hub as the route reflector server, and these two will be route reflector clients. Sorry, it's not visible. These are my route reflector clients. Yes, tell me. So let me go to R2 and remove that full mesh. Show run pipe section. No. Go to R3. So router 23. So no neighbor. 16.123.2. So what is the remote is 120. Enter. How to create a route reflector server? Any idea? Very good. Route reflector
client.
client.
Yeah, one.
Sure. Pipe section. So on the server, you need to tell who are your route reflector clients. So just copy paste this. Only one command, that is route reflector client. Enter. So 123.3 route reflector client. So what do you remember route reflector client is? So whenever your R3 advertises the network, so R1 will be having that information. It will just reflect to the other clients. So we have only adjacency with the server, not between the spokes. We don't have any IBGP adjacency here. In order to remove the full mesh, we use route reflector concept. Okay. So now go to R2. Show IP. Everything I have. Ping. And trace. This is about BGP. So anybody has any doubts? So tomorrow we'll do with OSP. Once again, we'll repeat this. Doubts? Clear? So today we'll end up here. So we'll continue tomorrow with the same level. Okay. Thank you guys. So any doubts? Online?
Yeah, then this software, right?
Which one? UNG?
Yeah.
You
It's
keep
a paid-
contact lab trainer. I think
Is
Arun's
it-
number you have?
Is it a paid one or
No, it's not paid one.
it's a free software, right?
Free software is. But he
Oh,
will
what
help
is
you to install. Arun, lab trainer. Just I will give his number. Please contact him. So we'll guide you how to install the event. Just
Okay.
take his number. 1 minute. It is 9611 844 128. Arun David. He's our lab trainer. So we'll guide you to install the UNG or GNS3 or packet trace.
So if I make self self next open R1, then next up will be only R2.
When you use next option, that is I'll take it. Just me. It's okay. Okay, guys. So any other doubts online? Mohammed Selva Kumar. Clear, right?
Yeah, it's clear, but I just need to do the lab first.
Yes.
Please more,
Please
yeah.
practice. Otherwise, you'll not be able to remember the commands as well as the concept as well.
Yeah, that's right.
Okay. Thank you, guys. Have a nice day. Bye.
Thank you all. Bye. Have a good day.